All right, so this lecture is going to cover Newton's third law, and you probably have already heard about Newton's third law in your previous studies of physical science, but Newton's third law is this idea that for every action force, there's an equal and opposite reaction force. And so almost everybody has heard of this force, or heard of this law, but you probably don't really understand the minutiae of it. And the key to really understanding Newton's third law is that action-reaction forces act on separate objects. And that's fundamental. That's the idea that if I am pushing against this wall, like the action force is me pushing on the wall, the reaction force is the wall pushing on me. They're acting on two separate objects. The same numerical value, but they're acting on two separate objects. And that is really the key to understanding. Because a lot of people say, well, if the action is 10 newtons to the right and the reaction is 10 newtons to the left, don't those just cancel out? And that is where you have to bring in Newton's second law to really understand how Newton's third law plays out. Okay? So action-reaction forces act on separate objects. Newton's second law shows objects acting on a forces acting on a single object. So let's just look at an example to kind of try to understand that better. And so the example we're going to look at is a cannon that is firing a cannonball. And so when this undergoes an explosion, there's an action-reaction force. One is that the cannonball gets propelled forward, and so we'll call that the force on the ball. Well, no, let's call it this. Force from cannon on ball. And the reaction force is opposite, and it's going to be the force from ball on cannon. So that is Newton's third law played out. Okay, these two are action-reaction forces. They're equal in magnitude, but they're opposite in direction. Now if we think about how this plays out with Newton's second law. Newton's second law is that net force is equal to mass times acceleration. So if I think about my cannon, Newton's second law, I keep losing my cap. Okay, Newton's second law, so these are my forces on the cannon. The only force I have acting on my cannon is the force of the ball on the cannon. And that's it. Horizontally, that's all I have. So that should equal the mass of my cannon times the acceleration of my cannon. And then if I think about the ball is going to have its own set of equations. So Newton's second law for the ball says that the only force I have acting on the ball is the force of the cannon on the ball. And that should equal the mass of my ball times the acceleration of my ball. Okay, so that's where Newton's second law comes into play. Now, if we paired this with Newton's third law says that these two forces should be equal to each other. Okay? That the force of the ball on the cannon, so that this should be equal to this, but just in opposite directions. So that's saying that the force of my, if I can come over here, oh, I just totally knocked a bunch of markers off her. And something else, it's okay. Okay, so Newton's third law says that these need to be equal to each other. So the force of my ball on the cannon should be equal to the force of my cannon on the ball. So those have to be equal to each other. But remember that these are equal to other things as well. So instead of force of ball on the cannon, I'm going to write the mass of my cannon times the acceleration of my cannon. And instead of writing force of cannon on the ball, I'm going to write mass of ball on the cannon. Now, these quantities have to be equal but opposite. Ooh, I should put an opposite sign there. So they're equal but opposite. Now, if we think about the consequences, mass of your cannon. Mass of your cannon is huge. Mass of your ball, really tiny. Okay, but the products have to be equal, so that means the acceleration of your cannon is going to be tiny, whereas the acceleration of the ball is going to be huge. And that makes sense. We see that physically play out. We see the ball hugely accelerating to the right, and we see the cannon just accelerating a little bit over to the left. Okay? So Newton's third law, action and reaction forces, they're equal magnitude, opposite direction. They apply to different objects, so their consequences are different according to the specific object. Okay? We'll look at some more examples tomorrow and discuss this.